How are we going to do? You can put on the chat also. We are online, and then I start.
Yes, we are online now.
So, good morning, everyone. Just 1 second here, please. We are here for the second day of the Latin American Software Engineering School, the second school. I would like to start to thanking the support for ACM CBSoft. It was very important to the so we have this school here in Brazil, and today we will start with a presentation from Nobert Siegmund. He holds the software engineering chair at Leipzig University, and he will talk to us about validity in software engineering research. So, Nobert, it's my pleasure to present you, introduce you. You have the floor, please.
Yeah, thank you for the introduction. I just start sharing my screen. So, yeah, first of all, thank you for the invitation. So we have something similar like that also in Germany, where also young PhD students come into Dachstuhl and have also something like that, like an education on introduction to research methodologies and so on for software engineering, right? So that's why it's very important to have something like that here. And I really want to congratulate you that you have something like that here running, right? So it's really cool. Okay, so a little bit about myself. So I'm doing software engineering research in the area of performance optimization, in the area of energy optimization and configurable software systems, software product lines. So there's also a huge community also in South America doing software product line research and so on. And that's why also I've seen some of you there in the community events. So that's also cool, right, to also speak with you here. About the talk, so it's not, so here it's the validity in software engineering research is not about a concrete technique, right? So it's more like general advice, how to approach a research question, right? So to be aware of what trade-offs exist here when you try to answer a research question, right? So it's on a bigger level here, right? And I also will maybe sometimes ask you a question and so on, or you can also ask me questions, and we have the chat here in Zoom, and I think Ivan and Sergio also will watch over the chat, and then we will have room then in the middle of the talk and of course at the end of the talk to discuss and answer questions from your side. Cool. Okay. So yeah, let's start right away. Need to be on the right screen. Okay. So the talk is based on a paper we had in 2015. It was also a distinguished paper award at ICSI. And the paper here is on the top, views on internal and external validity in empirical software engineering. So it's a nice anecdote about the starting. The main idea of the paper was with my wife Janet here. So we were at the balcony and we were discussing a research question, and she said we should do in a very careful way, and I said no, we should do it in an industry, in an applied way. And we talked with each other, and then we thought, hey, we are having completely different opinions how to address a research question, and what's the right way, right? So what is the community thinking about that? And this was the idea that ultimately led to this paper and then also to the talk. And then I will also extend over the talk. But yeah, as a self-advertisement or so, right? So I'm really proud also of this paper, and this is also part of some paper reading groups that I've seen. So it will go into more detail, of course, what I'm presenting here, right? And this joint work also with Sven Apel, who also participated in the discussions and also in the development of that work. Okay, before I dive into, I want to start with a little experiment with you. So let's say we want to answer a research question, right? So, and a research question is, what is more productive to use, a statically typed or dynamically typed programming language? So the question I have for you, how would you try to answer this research question? Right, so I mean, there are always discussions around that topic. And how would you try to answer that research question? Maybe have a quick comment on that in the chat or so.
Maybe Leopoldo could answer this question.
Yeah, Leopoldo could answer maybe. Okay, so
I typed in the chat, right? You do a survey, right? I'm joking. Maybe run an experiment, but then you would have to define, right? Some measure.
Yes. So okay. In fact, this research question has been answered already before, right? In software engineering conferences, and with two fundamentally different approaches. So on the left-hand side, you see in a paper from Stefan Hahnberg, an experiment about static and dynamic type systems. And the idea here was to develop an artificial programming language only for the purpose to answer that research question. So in this artificial programming language, everything was the same for the dynamically typed and statically typed language, with the exception of the type system, right? So the syntax was the same and so on, right? Of course, you have then types, syntax addition, but everything else was the same. And then they had, of course, tasks, and they measured, for instance, the time it needs to solve the task, the errors, and so on, right? So this is a very, very controlled experiment where you control everything, right? And the ideas have to only one thing that changes, and that's the treatment here. And the treatment is the type system, the difference in the type system, right? Okay. On the other side, we have a completely different approach. The paper here is called "Do Static Type Systems Improve the Maintainability of Software Systems?" An empirical study. And again, it's also an empirical study, but a completely different one, right? There's no concrete lab experiment, but there was a study on real-world software systems, right? They studied the errors and so on, and compared real-world programming languages against each other, and wanted to find out whether whether in a dynamically typed language is maybe there takes longer time to fix a bug or less time and so on, right? So really a different setting here, but it's a realistic setting in this case, right? But the problem here is, you can already maybe figure it out. Are we sure that the difference that we find here on the right-hand side are caused by the programming, by the type system, or is it caused maybe because the first group uses Java, the other group uses Python, and these are completely different languages. They do not just differentiate in the type system, but in many more aspects, right? So we cannot be sure whether this is caused by the type system. On the left-hand side, we can be sure the difference are caused by the type system because everything is the same. But does the result here, does the observation apply also to a realistic context? Then we cannot be sure, right? And that's the problem we have here. So we have in the white, right, a realistic setting, how to answer this approach. And what does it give us? It maximizes externality. So we can generalize our findings also to other settings and so on, right? So it reveals generally occurring effects. And the problem here is that causes of effects are very unclear, right? So we cannot really point or really for sure say, okay, the observation is based on this difference that we try to figure out, right? in the lab or in the controlled experiments, we maximize internal validity of our experiment. So we can really reliably explain the cause of effects that we observe, right? Because everything is the same, everything is controlled for. We only vary one aspect, and when we see a difference, then we have a causal effect, right? But of course, this is a lab experiment. This is really an artificial environment and so on. So it's really hard to generalize here. And that's the downtime of that, or the problem of that. And so basically, we have a fundamental trade-off between these two approaches, right? Maximizing external validity and maximizing internal validity. And if you try to approach a research question, if you have a research question as a PhD student or so, and you try to want to answer it, you come to a point where you need to decide, okay, where do you go for? Do you want to be more in the realistic way, right? Do you want to maximize external validity, or do you want to maximize internal validity? Of course, we could also say, we could have like a balanced study, right? Maybe we have like a realistic setting, but we control for every factor. The problem is we would then need to, in this scenario, control for programming experience of our subjects, for human subjects, the ability to solve certain tasks, fatigue of these subjects, the time it needs to read, right? So the tasks, it's different from person to person. Color blindness, the background knowledge of the person, the education of the person, the intelligence of the person, ordering of tasks, instrumentation, familiarity with the study subject, and so on, right? So these are all factors that may impact the outcome of the experiment. And if you would need to have a balanced study, right, you need to control for all these factors. And here we have only a fraction of all factors, here 22, and 23, sorry. And then we would need 2 to the power of 23 different groups to really control for all factors if we want to have really such a kind of study, right? You can imagine what this takes. So if you take just a couple of persons per group, you end up quickly at the population of Germany here, right? That you need for your experiment, right? So it's incredible. So it's not doable in practice to control for everything, right? And that's a huge problem here. So so basically, you have this trade-off, and you cannot have both at the same time. That's what the message here is, right? And so we wanted to know back then what is the state of the art, or is the awareness of other authors in software engineering, right? So we did a little literature survey back then, beginning from 2011 to 2013. And the goal was basically to get an overview of the awareness of these choices regarding, do I go to external validity or internal validity in my research question, right, in my methodology. So, and we analyzed over 400 papers in the survey from major conferences here, and which have empirical kind of empirical study in it. And here are the results. So 94% of the papers used an empirical method, right, to evaluate their approach, their theory, and so on. And only 8%, very interesting, reported on a replication study. Of course, back then, maybe replication was not such a huge deal as it is today, or today I would also not say it's a huge deal, but it's a little bit more, the awareness has increased there. But we will come to the importance of replications later, but you see that only 8% have reported on at least a part in a paper was a replication. So not the whole paper, but at least a part of it. Just to repeat what replication is, based on Wollin et al., is a repetition of an experiment under similar conditions, but with specified variation. So it's not a reproduction. It's a difference because then you have everything the same, but replication varies a little bit. Maybe the students are different usually, but also other conditions like different tasks you give them and so on, right? Okay. Interestingly, nearly half of the paper did not mention threat stability. They did not have a section, caveats, or threat stability in the paper at all. So let that sink a little bit. We have shown that nearly every research question has to make the choice between external and internal validity, right? But then you have a threat stability on the other end, right? But half of the paper did not report anything about that, right? This is very interesting. That was also, so I also participated in the survey, and I interestingly found that in the testing papers, so papers about testing, none of them had mentioned threat stability, right? So they presented some new testing approach and so on, right? They throw this testing approach to a bunch of systems and so on, and then that was a paper. But there was no discussion about where are the limitations, right? Is there really a causal effect recognizable that we can be sure that actually the testing approach is responsible to detect maybe more errors and so on, right? So nothing was there. So, but it was about 10 years ago, but it was really a sobering result there, right? Okay, and from the other paper, so 28% discussed threats, but did not differentiate between internal and external validity. There are also other kinds of validity like construct validity and so on, right? But they just mentioned, okay, we have a threat to validity because we did not measure all systems in the universe and so on, right? So the problem is they did not really put their research into context of these threats, right? And they're very general, and which is also creates a problem, right? When you want to apply or when you want to develop an approach that tries to maybe even compare with the approach or be better, when you do not know what are the limitations and so on of the other approach, right? Okay, you could say, who cares, right? So, I mean, I just could go for maybe maximize external validity, and who cares, right? And especially when you go for external validity, which is nowadays like the golden standard in conferences, which is not. So I'm not a fan of it, because you have to have impact always with each paper, right? So all the call for papers mention that you need to be significant, you show significance for the community and for practitioners and so on. But this is a huge problem, because this focus severely on max of external validity. But as we now know, hopefully we miss the other part back then, right? The internal validity. And concentrating only external validity is especially a problem for practitioners, because here I state the question: what's the main question of a user before adopting a paper's approach? What do you think? What could be the main question there? Do we have something in the chat? So what could be the main question?
There are some answers in the chat. Maybe people could just open the microphone and speak. What do you think, Nobert?
Yeah, you can also. Yeah, sure. Yeah.
Go ahead, Leopoldo.
How will I benefit?
How will I benefit? Yes, that's part of it. right?
Patricia, Leonardo, go ahead.
Can I trust the results?
Yes, can I trust the results? That's right. I have just another phrasing, so I'm exactly on that point.
Leonardo says, can I reproduce it?
Yes, it's always the same. It's basically everything is around. I have here, would this work in my case, right? So can I reproduce it? Can I trust it? Would this work in my case? Because as a practitioner, when I read a research paper, right, before I even start to think about adopting the approach, I have the question, would this work in my case, right? Because if this does not work in my case, then why bothering with implementing it and so on, right? And so that's the very first question. But to answer that question, right, we have this cause effect. So, and we had here from Patricia, I guess, was it, can I trust the results? Can I trust the treatment, right? And this requires internal validity, right? So it requires that you have an approach, an experiment set up to be internally valid, that you can have a really cause effect chain. If you do not have this, then how can you answer that question, right? And the other case is, you, of course, in a company, you have a different setting, right? Like the one in the research paper, right? That's of course different, right? So this is why the question is, does it have a similar effect in a changed setting, in my setting, right? Does it behave similarly? And this requires external validity. And so you need both, right? And but to have both, again, you have really completely different approaches to show it, right? To prove it. So another group of persons, who cares? I would say you should be concerned with that. You as authors and reviewers should be concerned with that. Why? Here's an example. So who knows the NIPS experiment from you? Some of, okay, Leopoldo. And so NIPS is a machine learning conference, so neuro information processing system, or AI conference, really huge. And in 2014, they made an experiment. So they split the PC committee, the PC in 2 independent committees, and they evaluated 166 submissions twice, right? So in both committees. And then they compared whether the paper got accepted in both committees, so whether they agree and reject it also in both, or whether they disagree. What do you think was the outcome? You can just scream at me.
I'm sorry. I think probably there was a lot of variation in results.
Yes, a lot of variation is conservative. It was close to random acceptance. Let that sink in. Close to random acceptance. It's hard, right? So that's a completely failure of our reviewing system. When we have a random chance of acceptance, so why do we review papers, right? It's not entirely random because there were clear accepts and clear rejects, right? But the huge majority of the papers were, some reviewers accepted it, some reviewers rejected it. And we need to ask, right, ourselves, what can cause such a randomness in this process, right? And we claim here that at least to some point, there are different expectations by reviewers, how to write a paper, how to approach research question, right? How to come up with a research methodology that's appropriate to a research question and so on. And this is exactly the stressing point that I made before with where to go, right? So we started from there. So we wanted to know what does the community think about the awareness of this trade-off between internal and external validity. We want to know what is the opinion, what are the approaches of the community to address this trade-off, right? And finally, we already knew back then that replication play a crucial role to go from an internal valid study to increase external validity, right? When you replicate something and in a different setting, then you increase external validity, because this is how science is done, right? In other research fields and so on. Look at medicine, biology, and so on, right? You need replication to really be sure that the treatment actually has a causal effect, right? So that's also, we ask also for the role of replication. And whom to ask? We ask PC members of major software engineering venues, so conferences and also reviews for journals. And we contacted over 800 people. And we got feedback from over 90 people, which is really, in the survey, 10% is really a typical response. So if you are higher, then you are lucky. If you have a higher response rate, right? But still keep in mind, it was May 2014. So of course, opinions change over the years, education of reviews change over the years. But maybe, so we will come to that later, maybe not always in better terms, maybe, right? So to give you some impression, can you read everything? Because the overlay of Zoom is maybe stuff like that.
It's readable.
Okay, good. So right, so our questions were like, first of all, thank you if you took part in that questionnaire, right? So something like that. So which option would you prefer for an evaluation? To maximize internal validity, maximize external validity, or have no preference at all, right? In this case. And we started also with the same thought experiment that I introduced in this talk about the programming language to actually know, okay, what is the setting here, right? We ask. Other questions like, did you recommend to reject a paper in the past, mainly for the following reasons, like internal validity is too low, external validity is too low, right? Or do you think we need to publish more experimental replications? Yes or no, right? And we had then also many open questions. And for open questions, right, you can type in your answers, your textual answers, and then you need to evaluate that. And for that, we had an open card sorting as an analysis method for that. So how does it work? So we sit really in a table, we print out every answer on a sheet of paper, and then we take one question, and we took about 2 hours per question. And we try to sort the answers into topics, right? And come up with similar responses, different opinions, and so on, and revised and refined that. And it was very good that we had Janet on our side, because Janet was like the referee there, because she is very educated in these empirical methods. And Sven and me, we were often talking about interpretation already of the written text, right? But it's really important to not interpret the answers there, but to really be objective, right? And to not fall too early into conclusions and so on. And that's why it's really difficult to do that in an objective way, right? It's not so easy, right? Right. So you can see, so it takes a lot of time to do that, but when you do it more often, right, you can also have at the end of such a session also a beer and so on, right? So don't take the fun out of it, of such a task, right? Because it was also quite cool. Okay. So about the results. So the first research question was about the awareness of the community regarding the trade-off between external and internal validity. And interestingly, we found a mixed degree of this awareness. And we had comments something like that. Maximizing internal validity would show no value at all to software engineering community. so I always pause after reading that because it a little bit shocks me, right? Maximizing internal validity would show no value at all to the SE community. It means establishing a causal relationship, right, from treatment to effect has no value at all. So the sentence is really incredible for me to state something like that. But this comes from a review of a major software engineering conference, right? And on the other side, without internal validity, the results cannot be trusted. So we have the complete opposite of this opinion, right? And now you as the author of maybe your first or second paper, right? You get these two reviewers assigned to your paper. You lose. You always lose. You cannot get the paper accepted with these two different expectations. And that's why we may see this close to random acceptance, right, in conferences, because reviewers have just different expectations about how to approach a research question. And this is really astonishing results that we had here, right? So that there are so really sharp or harsh viewpoints, right, on the right and left end of the spectrum, right, here for these validities. And when you have human subjects, so we asked also the questions whether it makes a difference when you have human subjects in your empirical study or if you just measure performance or whatever, right, or test something. Then we got questions like, removing humans from the exercise reduces the challenges for internal validity. In that context, knowing how generous approach would seem a more important issue to address. So if you don't have human subjects, then you should aim for external validity, right? But another one states, it makes no difference with or without humans. We are talking about software technologies because software technologies are for humans, involve humans and whatever, right? So it doesn't make any difference. So we should treat them equally, right? And again, if you have both reviewers on your paper, you may have a problem, right? So one thing about our own study where we saw the problem of internal validity. So you can see here performance data. So on the x-axis are commits, and for two software systems, and GNU-XZ and a video compression system. And we measured for every commit the execution time for a benchmark, and we plotted it, and the y-axis shows the performance difference, right, that we see from one commit to the other, right? And so you see really interesting patterns here. So we were looking into performance evolution, right, of a software system. And we were really cautious. We measured every benchmark, every execution 5 times. And then we used the average, right, to not have outliers and so on. And we really controlled the system to have only this application running and nothing else and so on. And we saw this cool patterns. And we wanted to write a paper about that. But then we said, they seem to be oddly regular. Is it really here the cause? So we hypothesized that maybe some commits introduce new feature code that slows down the system. Then you have some maintenance commits, right, to improve the performance again. And this is like the cycle, right? So, but we thought, no, this is just too regular, this paper. It cannot be, right? So, and we thought this might be a threat to our internal validity, right? And so we repeated the measurements again on an identical system, right? Again, with repetitions. And then we found this pattern. It is no pattern at all anymore, right? It's random, it's noise basically, right? So because we were aware of this fact that this problem occurs, right? We went back to increase our internal validity, right? And measured again the system, and then we found, okay, there are no reoccurring patterns there, and so on, because our internal validity was not high enough, right? So as we wrote the first paper, we will come to the thinking about what are our internal validity, threat validity, and then we tried not just to report it, but we tried to really address the threat, and then it turned out to be entirely different, right? So, and basically what we did here was like a replication of our first experiment, but on a different but identical system. But the ordering of how we did these reputations were just different, right? So we did not measure every commit subsequently, but we had just the commits measured in random order. And then we found out, okay, there were really internal processes at the machines that we could not kill, although we controlled for that, but there were really some internal processes that were very regular and that caused these patterns in the first place. So yeah, and this is also how research turns out, right? So we did not write a paper about that. Okay. So about the quantitative results we got from so which option would you prefer for an evaluation? The PC member said external validity in nearly half of the cases. So nearly half of the cases said we want to maximize external validity. And 15% of the cases of the reviewers wanted to maximize internal validity, and only 15 to 16% or so had no preference at all. Some didn't answer here, so that's not why not all answers are here. So this is really interesting, because if you have a preference about how a research question is answered, then when you submit a paper and you do not follow the preference of the reviewer, you may already have a problem in convincing the reviewer about the significance of your work, the implications of your work, right? And this is really problematic then to get also your message out, right? And with human subjects, interestingly, there's a little bit goes from external validity to no preference, but basically external validity still stays at the top here, right? So for our second research question, or do you have any questions so far in the chat?
No questions here.
Good. If you have questions, just type in. Yeah, then I will just continue. So for the second research question, so we want to know how to address this trade-off. So what is approached by the community, right? The problem is that a single study is not seen as a piece of a puzzle, but requires immediate practical impact. So if you have a larger research endeavor, right, like your PhD thesis and so on, then of course you have several steps in your PhD thesis in order to reach your end goal, right? But now with the focus on external validity, with the focus on practical impact in all these core papers, every step you make during your PhD must have a practical impact in order to be published. And that's the problem, because then we cannot work and publish work, or we cannot work on larger research endeavors or research questions in which intermediate steps may have not practical impact, because they are maybe ground research, basic research, right? Where you first need to develop a methodology or so, or a theory which does not have a direct practical impact. But just later it becomes, maybe when you show, okay, based on the theory, I can develop tools and so on that help develop. Only then you can publish something. But before that, you cannot publish something because it has no direct or immediate practical impact. And that's the real problem. That's a huge problem. And also this was already made 7 years ago or so, this questionnaire, it's even more concerning right now with the core of papers that exist today. And here interesting comments to that. So studies in medicine or biology have hundreds or thousands of participants over several years and address very narrow issues. We don't see their studies that use 20 participants are done in 2 months in an attempt to answer questions of the caliber, is CT better than MRE, right? But this is how we approach our research in our field, right? Or I am worried that maximizing internal validity easily creates overly academic papers that provide little impact. So I thought we are academics. I thought we publish in an academic conference and not in an industry conference. So why are academic papers here now a bad sign, a bad thing, right? Why are internally valid studies are now considered to be a bad thing, right? If you want to have practical impact, why don't you publish in an industry conference, right? Because there are a lot of industry conferences where the practitioners are, thousands of practitioners are there, and then you can go there and have your approach, your tool published there. You can do that, but why do we should be become so solely focused on practical impact, right? I do not want to condemn that, but I just want the sole focus on practical impact. It's hampering us. And without internal validity, right? What most studies find is correlation. They don't find causality, right? And that's the problem. I hope everyone knows this picture about the difference between correlation and causation. And if you only go for external validity, you can only prove the correlation, but you cannot prove the causality. And so here is the definition there. The purpose of an experiment, however, is to show that two variables are statistically related, and to do so in a way that supports the conclusion that the independent variable, so the treatment, right, caused any observed differences in the dependent variable. The dependent variable is what we want to observe, right? The outputs, for instance, the performance that we observe. That's the dependent variable, and the treatment or the independent variable is our approach, right? Where we vary something. So an empirical study is said to be high in internal validity if the way it was conducted supports the conclusion that the independent variable caused any observed difference in the dependent variable. So causation here requires internal validity, right? And if we look again, maximizing internal validity creates overly academic papers. We have no causation anymore, right? In our conferences, we have no, we cannot trust what we said before or heard before. We cannot trust the results anymore, right? Okay, so do you prefer more practically relevant or more theoretical or ground research? So practically relevant, nearly 40% of the people here voted for that. No preference had 1/3, and ground research 8% or so, right? But the question is, what has at the long term more impact on society and industry, right? It's usually not this tool that's published in a year, right? And then forgotten the next year, right? So regarding replication, right? Other interesting results here. So how often have you reviewed a replication back then? So never, 40% of the people, sometimes about 1/3, and regularly maybe 2% or so of the people, right? How were the replications rated? That's very interesting. By you. So these are all reviews of the same conference. Keep that in mind. These are reviews of the same conference. They accepted papers way more often than they rejected it. But all other reviewers rejected it way more often than, right, accepted it. that sounds contradicting, right? So of course, we did not get the whole population there, but I think it already tells the story here, right? So how you perceive yourself in this review of a paper and what is actually going on, right? So, and we all know that replication publishing, or if you do not know, getting a replication published is really a hard work, right? So, and at the same time, do we need more replications? An overwhelming number said yes. So keep that in mind. So most of these people said we need more replications, and only 8% said no, and the rest was not sure, right? Or didn't answer. So interestingly, in the open questions, open text fields, most participants appreciate replications, but see that they are difficult to conduct and publish. Yes. So I have seen few replication perform myself, a few, because they are too difficult to publish. There will always be a dumb reviewer to say this is not novel, right? So we will come back to this novelty and so on in the second half of the talk, but keep that in mind, right? Getting a publication accepted that doesn't contribute anything but a new experiment while assessing the same question, not even adding artifacts, is a good example of hunting for publication just for the sake of publishing. Come on. So here's one reviewer said, if you replicate something and it's basically, or reproduce a result, right? It's just hunting for publication. So you just want to have a publication for free. Come on, why you do that? Right? It doesn't add anything to our body of knowledge. That's incredible, because only by reproduction, replication, we can increase externality, show that it's applied in different applications, that we can generalize our findings, and that we can actually trust the results. So interestingly, so I also done a replication of a paper which was cited a couple hundred of times, and we found contradicting results, right? In our replication, but nobody cared, because this was not really wanted, or is still not wanted in conferences. So I still don't see any replication track or so, right, at ICSI also. So this is basically not wanted, and also it's not valued by the community, right? Although you can sometimes even prove that what others rely on is actually wrong, right? But if you do not do the replication or reproduction, then nobody can actually find out whether the original results are correct or not, right? So yeah, replications are appropriate to address the trade-off. So this was confirmed by the reviewers. Yes, we can address the trade-off between internal and external validity with more replications. So we can go from internal valid studies to more external valid studies when we have more replications, but they are missing incentives to do so, right? So it seems that replication is rarely done, since it is costly, hard to do. Often not all details, tools, software, or data sets involved in an earlier study are available, and it carries a low impact factor, at least in certain venues. So what does it mean? It means, for instance, of course, you cannot find the original source code, the original data. It's often on web servers that are not available anymore, or whatever, right? This has improved in recent years. But still, if you replicate something, and even if you manage to publish something, who's cited? Of course, the original paper, because the original paper came up with the idea. But if you are never cited, then you do not get impact of your work. And if you want to become a professor or whatever, right, then citation counts, sorry, right? And if you invested your time, your months of work into a replication, which is really important for the community, but has no gain for your career, right? then it's for you a bad investment, right? And furthermore, there are no standards how to conduct replications. So, for instance, one said it depends whether the findings contradict the previous ones. So it only makes sense to do replication if you find a contradiction. How can you know that in advance? Right, you cannot know it, right? You do not do replication when you already know the result. So that doesn't make any sense, right? So that's a problem. And also problem is that you then publish only work that contradicts others, and you do not publish work that approves or verifies the work of others, right? Which is essentially a problem by itself, right? So these are somehow the results we got already back then. And now let's see how this maybe has evolved in the recent years, all right? So, but I make a little disclaimer here. So controversy ahead. So it's okay. So I want to tickle also some points here. You already have seen that I really question how we do our call for papers and how we emphasize some of the things in our conferences. And this is maybe a bit controversial. At least the PC shares of the last major conferences are all in line that we want to have impact and novelty in all of our papers. And I will show you some prominent and important examples that this is maybe not a good idea to rule out the other side, right? But first, let's talk about external validity and ecological validity. Oh, where does it come from, ecological validity? So external validity is often taken for practicality, and it applies to the real world, right? So we had here the comment external validity is very important since it provides indications about the potential for industrial adoption, right? That's wrong. The definition is ecological validity is often used to refer to the judgment of whether a given study's variables and conclusions, often collected in a lab, are sufficiently relevant to its population, e.g. the real world context. So what we actually ask for is basically ecological validity and not external validity in all these calls and so on, right? That's the first mistake we make. And to quote further Wikipedia about external validity, if the results from such a mock jury study are reproduced in and generalized across trials. So here we talk about reproducibility or reproduction and generalized across trials or replication, where these stimulus, materials, and settings and other background characteristics vary, then the measurement process may be deemed externally valid. So here we have it, really the definition of Wikipedia, the definition of external validity requires reproduction and replication. Otherwise, you don't have an external valid study. So external validity refers to the ability to generalize study findings in other contexts. The other context is not the same as in a real world context. It's just another context, right? And ecological validity, the ability to generalize findings to the real world, is a subcategory of external validity, right? It's a special case of that. So, so it's quite interesting that this term is used in a wrong way. And that we usually want in our conference and journals more ecological validity of our studies when we want to have impact, practical impact and so on, right? But if we want to have external validity, we need reproduction of the study and so on. So how to show practical impact then? A paper without replication and so on should usually not be then trusted that it has practical impact, because when you cannot show it, right, with a replication, then you basically have no external validity, right? So that's very interesting. So as I mentioned, external validity needs replication. So having a study in a company does not mean it is externally valid, because so if you have this in company A, it does not mean that it works in company B. It just means that it works in company A, right? That's not that it applies in practice, right? And this is often confused by many reviewers. So right, so that's again that we need reproduction and generalization. So if you want external validity, then either accept only reproduced or replicated work at software engineering conferences. That's basically the message here. And again, what you get, however, is this is not novel from reviewers when you do that, right? And or relax on criteria of significance or novelty and impact, right? However, then you get a reviewer, leave the ivory tower. If actual insights for people's lives are supposed to be the outcome of research, it better be applied to such problems. So leave the ivory tower means, right? So have really an applied research, but then you run into these problems with internal validity and so on. So it also touches these 2 points of ground versus applied research. So we already go a little bit into the direction of applied research. So external validity should be applied, right, to practical problems and so on. And ground research, right, or basic research or fundamental research, right, is often considered maybe not relevant or not significant in our conferences. So, right, so I'm worried that maximizing internal validity easily creates overly academic papers. So I would say ground research is considered here by this person as an overly academic paper, right? Because it has no practical relation or impact, right? So I had a discussion on Twitter about that as the ICSI 2022 call for paper came out, because the CFP also wants authors to discuss significance as the extent to which the paper's contribution can impact the field of software engineering and under which assumptions. So if reviewers miss this connection, feel free to elaborate further in the response. Then my answer is just, significance is hard to judge and very subjective. So how can you judge that a work is significant, right? How can you do that? Because it would need to foresee the future in 3 to 5 years. How can you do that, right? Ground research has substantially harder time or more difficult time to demonstrate significance than applied research. This can be a major obstacle for internally valid studies and replications. Shouldn't we drop it or educate the reviewers? That was my question to the call for paper. Unfortunately, it was not taken seriously. Didn't expect that, but I wanted to start a discussion about that, right? So, and the main thing that is asked for have significance and impact, right? And there are these guidelines out, the ICSI guidelines, review process and guidelines of ICSI 2022, and I think that's now reused in other conferences and adopted, right? Let me first give you a disclaimer that although I now will criticize some aspects of these guidelines, I want really to say thank you for Daniela and Andreas to putting together such guidelines, because as we said before, there were not really guidelines for reviews before. That is why these different expectations are there, right? And writing down guidelines allows us for the first place to discuss whether these guidelines are or should be improved in certain aspects. But if you do not write it down, then you cannot discuss about that. So that's why it's really important that we have something like that. And that's why we need to thank you, these two, for putting this together, right? And it's really a step forward, right? also now we can also discuss about that. And these guidelines have 5 points here, which should be addressed in the review: soundness, significance, novelty, verifiability, and transparency, and presentation. And I would say the soundness of a method, the verifiability, and the presentations are easy to verify if you are familiar in the topic, if you know your research methodologies. And as a reviewer, I would expect that you are, right? You should be familiar with research methodologies. Otherwise, you shouldn't be a reviewer, right? So, so this you should be easily verifiable, right? But significance and novelty are really hard to judge, right? Right. So let us take a look into significance, what the guideline says. So we expect papers to be significant. Hence, you should evaluate how their contributions can impact software engineering practice. So ecological validity, right? And so what does it mean? External valid studies and ground research are here at least out of the window from my point of view, because the practice with a theory of mind or whatever about a programmer, how can you show what's the impact of software engineering practice? That's really, really difficult, right? So let me skip to that. Do you consider that the path towards impact may be long and winding and subject to several assumptions? So here was a little bit that I said, maybe the impact can come later, right? But how would you even evaluate that, right, for basic research? The path towards impact may be long and winding. What does it even mean? So I don't know, right? So what maybe remain for the review, because this is really hard to evaluate in a paper on, be cautious about accepting a paper that has little significance, right? And we see significance is defined as having impact to practice. So everything which has no impact software engineering practice is considered to be not significant and should be rejected. And that is a really difficult road here that we go, right? And this should be set. And this is basically what we already saw 7 years ago. This is comment, right? Getting a paper publication accepted doesn't contribute anything but a new experiment. And so it's hunting for publication. So that's a problem, because other fields already found out that that replication and not going solely on significance novelty is really important to have validity in your research, right? And here's a paper that analyzed basically the null hypothesis, and it also found that because you don't publish so often your false result, but you publish often correct results, that if you do something like a statistical test, you have always a chance to still be wrong, right? And then that this can add up. And if you do not have replications and reproductions, you will never throw out this error, right? And so there are some papers about stressing that point, right? And this was in another research field, but also for computer science, and especially empirical computer science, where we see that threats of a replication crisis. And here's an interesting comment or citation here: if you do not live up to the traditional standards of science, there will come a time when no one takes us seriously. I know there's a discussion whether software engineering is computer science, because we are called engineers, right? And engineering is not science. But if we have research questions, if we have research methodologies, then of course we are here in a science area, right? We need to have theories, we need to show causes and effects and so on. We need to do it in a scientific way, right? To have trustable results. And this quote here says it, right? If we do not live up to traditional standards of science, there will come a time when no one takes us seriously. When we put out papers that are not replicated, that are not verified, right? And that always fail when they want to be adopted in practice, then of course, no one will trust the results anymore of these conferences. Yeah, so this is also discussed the fire draw bias that exists, so that I mentioned a minute ago. So correct findings of no effect are unpublished and hidden from view. And through publication bias, a single incorrect chance finding can be published and become part of a discipline's wrong knowledge. So you build up wrong knowledge, right, in your community. And the recommendations were pre-registration of studies, and there are already journals who have pre-registered reports. So I really encourage you to do something like that, to rule out some biases that you may introduce. So it goes like that you come up with a research design of an experiment, and you submit this research design of your experiment. And this experimental design then gets reviewed, and if the reviewer think, okay, this is a valid research question, also your study design seems to be plausible and sound and so on, then the subsequent paper, no matter what the results are, right, get published, right? And that's a good way of also publishing negative results and something like that, right? Because it was a plausible research question in the first place, right? Right, and another recommendation was encourage replications and educate reviewers, right? And I see a little bit with educate reviewers, this reviewer guidelines, educate reviewers, but on the wrong side, or doing it, emphasizing it too much on practical impact and leaving out replications and basically the standards of science, yeah, if we take it really dramatically. And we have this also in AI, right? And if you look into ICSI or ASE or whatever, half of the papers have a machine learning component nowadays, or an AI running. And so it's really relevant also to our community. And they are wrestling with the replication crisis, right? And yeah, AI already suffers from the black box problem. It can be impossible to say exactly how or why a machine learning model produces the result it does. A lack of transparency in research makes things worse. Large models need as many eyes on them as possible, more people testing them, figuring out what makes them tick. And this lack of incentive for replication is a barrier to such efforts throughout the science, not just in AI. Replication is essential, but it isn't rewarded. So that's in this paper here. And what this means here, for instance, you have huge language models or whatever AI models you have, right, who cost thousands to hundreds of thousands in training time, for energy consumption and so on, right? And nobody can replicate this model because nobody has the infrastructure, the resources to do it, right? And so nobody can replicate it, the findings, then nobody can trust it basically, right? So you have to really believe what the authors state in a paper, right? So you need to trust their word basically, but you cannot verify it in another study, right? And this gets increasingly problematic in machine learning and AI. And since we are adopting more and more machine learning and AI, this becomes also our problem, right? So yeah, so do we follow the path of machine learning and AI, right? So here's quotation about International Conference on Machine Learning. I reviewed 3 papers for ICML. All 3 had fundamental flaws, like theorems that are demonstrably false. None of the other 6 reviewers, right, noticed these flaws and gave thumbs up. This is the sorry state of ML conferences, right, from this year. I've had similar experiences. I feel that we have nurtured a culture in machine learning where it's easier to get published if you deliberately write your paper in a confusing way. make it sound impressive, but leave out important details, and the reviewers will not dare challenging you. But they probably looked novel with SOTA results, so that you have better results on a comparative benchmark, right? So they look novel. And that's a little bit the fear that I have here also, right? When we don't have internal valid studies where I can really cause effect chain and only look into novelty, that we run into the same problems here, right? So going back to this ground research versus applied research and significance novelty, right? So this small Twitter rant went on. So I mean, ground research, right? Maybe you have been vaccinated, but in order to have vaccines against COVID, right, it required 20 years of research on mRNA, right? And with no practical impact back then, right? And only now we had a short time period with practical impact, and where it became significant. The internet was developed for better communication between government and research institutions. There was never meant to be businesses on then, right? Or that connects people and so on, right? And now everything runs on the internet. We are talking here, right? I talk from Germany to you, to Brazil, right? Or South America via the internet, right? And this was not clear back then, right? And but going back to maybe software engineering, so maybe everyone or most of you have heard maybe REST APIs, the approach to communicate between microservices and so on, right? And this was basically proposed in a research paper in a software engineering conference, and it was Feeding who proposed this principal design of the modern web architecture back in 1999 at FSE, and he was rejected because the originality of the paper is quite low, and I can't, or another reviewer said, I can't find novel lessons for software engineers, right? And now, so Feeding gave a keynote in 2017 about that, and now most of the internet services use REST APIs and so on, use the ideas presented in the paper, and it had a huge impact, right, on society and software engineering. But it was rejected back then because it was not novel or had no impact, right? So originality was low. And if we reject these papers, right, because of these issues there, then we reject maybe the most influential ideas that we have in our field, right? And maybe an example that you can also follow is neural networks. And maybe you have heard about the term AI winter. And it was back in the late 60s, 70s, where it was found that a neural network cannot solve an XOR problem. And then it basically killed the research on neural networks. But so because you have no practical application for neural networks. But some people stayed on this research, right? And they invented something like back propagation, although it was invented in several places, invented multi-layer perceptrons, RNNs, LSTMs, and so on, although it had no practical impact, right, at all. And only in the last couple of years, right, it skyrocketed the practical impact because now hardware was available, data was available, and so on. But over the majority of the time, it had no practical application at all. Right, would have been rejected all the time, right? And so leave the ivory tower. Why, if we would have left the ivory tower, we would not have deep learning today, right? That's the message here, right? Because the ivory tower was in this time period here. And now we live in this time period, we cannot live without AI, right? And that's crazy, right? And we are heading into such a field where we do not value anymore this basic research, right? And even the AI research even states that, okay, gradient descent can write code better than you. I'm sorry. So now they even claim software engineers are not really needed anymore. We just generate our code, right? So this should be a warning, maybe to us, and it touches every one of you by writing papers, by developing a good research methodology. Be aware that reviewers think currently how they think, and if you are back maybe later in a place where you are a reviewer, maybe you can also think back to this talk and look maybe also to the other side, which may have value also, right? Like controlled experiments and so on. So that's the last slide here, right? So try to put everything together. So where are we heading? So we talked about internal validity, which is called ivory tower research, often more toy examples, because you really control everything. And since you can control everything, you cannot really have practical bugs or huge software systems that you analyze, because there are so many different confounding factors floating around that you cannot control for, right? And that's why you need to really strip down every complexity and only focus on the one aspect that you want to analyze, that you want to treat, right? And this is increases your internal validity, and it establishes basically causality and trustworthiness, right? And this is often done in ground research, right? So when you have something like, okay, I can trust this cause effect, then I can do replication in different settings with different subjects, with different artifacts and so on, right? So you can now to find out whether this generalizes this cause effect chain to other settings, right? So, and this increases then your external validity. And then you can increase, for instance, or import industry examples and so on. We have a larger range of settings and so on. However, this is already misconceived as when you have an industry example in your paper as significance or impact, because you can now show, okay, I can find this bug in this real world application, right? But can you find this bug in another real world application? You can only say if you followed all the circle from the internal validity, right? If you did not do that, if you just started with external validity or started with an industry example, then you cannot say that it generalizes to another example in industry or practical example. So the problem is, however, this becomes our evaluation criterion in a conference, right, or in a journal. But the people actually ask for ecological validity and practicality, right? So significance, novel impact, what I said, we cannot have it without trustworthiness and causality. And this is what reviewers need to be educated, what PhD students, postdocs, professors need to be educated, that we cannot have impact when we cannot trust the mechanisms behind an approach, right? And so this requires to have internal validity, but this is actually currently not valued, right, to have this. Yeah, and so you can somehow say it, okay, the left-hand side is industry-centered fundamental research on the right-hand side, but this is how people think about this subject, and they want to be more having on an industrial side, you are engineers, and we need to have working solutions in the practice. But how can you have working solutions when you have no cause effect chain? That's what often is missing, right? Because engineers also follow physical laws that have been established by ground research, right? And they base basically their engineering skills on that, right? And that's what often people forget. Yeah, right. Yeah, so bottom line, sorry. One reviewer put it really in a nice way, right? We don't know what we are doing, right? Yeah, that's I want to close with that. Maybe it's a good slide, and head over to you for questions or something.
Okay, thank you, Norbert.
Yeah.
We are a little bit out of time, but I
yeah,
mean,
sorry.
the subject is very interesting. The subject for sure. We have a couple questions. I have some of my own. Let's see if we can use a little bit of the break for that. Since we don't have food, that's okay, right? Otherwise, people will be running for food now. So, Patricia, do you want to open and ask the question you asked on the chat, please?
Okay, thank you. Oh, hi, Norbert.
Hi.
My question is related to the lack of novelty and hunting for publications argument of reviewers regarding replications. I mean, how do we respond to such comments or prevent them in the first place when writing a paper reporting a replication study? Do you have ideas for us?
Yeah, first of all, it's problematic. So you first should select carefully the venue where you submit your paper, because this already decides whether you have a chance at all to get accepted, right? And then you should make it really bold how important a replication is. So repeat this, make it emphasizes, make it really bold statements there. Why is this replication is important and why did you do it, right? Because otherwise reviewers don't get in the state of mind that actually we are doing here something important and this helps science and so on. Of course, I would not write this in such a general statement. I would really focus on why is this important to replicate this paper and so on. And then you should convince basically the reviewer that doing the replication is important and the results should not matter, right? And this needs to be right in the abstract, in the introduction, in the some reviews want bullet lists in the introduction of the contribution, and so on, right? And in the conclusion, and so I have it in all over the place repeated that why this is important, and if you win the reviewers to acknowledge that, then you have won, I would say, right?
Thank you very much.
Shirley, you wanna go now? I'm not
Hi,
sure.
hello. Yes.
Go ahead.
Can you hear me?
Yes.
Hi, Norbert. Great
Hi, Shirley.
presentation subject. I'm really glad that I had the opportunity to watch it, especially because I'm starting. I'm a PhD student. I think you already answered my questions. That was about that science is done on replication. So I think you summarize it, that you have to educate reviewers and authors. So I have actually, now that you answered Patricia, my last question would be, how do you explain all that, emphasizes the importance, put the reviewers in the intended state of mind while presenting some results in 6 or 8 pages?
Yeah, I have also the feeling that replications may be better suited in journals. First of all, you have more space there, right? Because you may need to write about the original paper or something, right? And you need to really explain what you have varied in your replication and so on. And so you don't have this 6 or 8 pages issue. And another benefit for a journal is that you may come easier into this major revision round. And if you go into this major revision round, then you usually have won, right? Because it's not rejected, and you can now answer the reviewers their questions and even stress that point even more in the answers, and you get also the questions from the reviewers why they may what problems do they have, and you can react on that, right? And that's why it's easier also for replications to publish them in a journal instead of a conference, because in a conference, that's right. Usually, also you have some conferences have rebuttals, like questions where you have 3 days time to answer questions from the reviewers, and then they can read your rebuttal. They are not forced to do so usually, but they can read your rebuttal, and then they may change their mind. However, I have seen that very rarely, and I had also the impression, especially the last conferences, that rebuttals are usually not taken seriously to change the mind of the reviewer. They may accept some of your answers, but stay at their opinion because you have only, I don't know, 500 words or so in your rebuttal, and I can make an example. So I had some 7 points or so, right? We answered everything, so we submitted a rebuttal with 2,000 words. And they said, yeah, okay, you answered these 6 points, but this 1 point, it's not fully answered for me. I keep with my rejection, right? So, and then, okay, right? And the problem is not about the single incident. The problem is that reviewers at the conference usually have no time, because they have 14 papers or so that they have to review and that they have to discuss and that they have to read rebuttals and so on. So they have really no time to question their own judgment, maybe, because it takes really time to rethink everything. And for a journal, you have just a single paper usually, and you have more time to think about that, and that's why it's easier maybe for replications. Yeah.
Great, thank you. Do you have any more questions from people? I have a question of my own. It's more like a comment / question, maybe. So just to give you Norbert a little bit of context, I have a empirical software engineering course here at my university in the graduate level. And one thing I used to say, I mean, the course is focused on control experiments, of course. And one thing I used to advocate is experiments should not be that suitable to do, to get like external validation. This should be the last validation you will be concerned about, because experiment is so focused. You are in a nano space of the universe researching. On the other hand, the research question gives you context about how practical or not is what you are researching, right? So if you have a research question that is somehow interested to some practitioner, to some firm, I'm not sure, or if you have people that work at that firm, let me rephrase that. If you are able to run the experiment in the firm, the enterprise, which is quite hard, enterprise let you do that, then you can have a so specific result that might holds only for that firm. And that's okay also, because I mean, it's the reality of that firm is as practical as it could be. And for sure, it's not generalizable for other firms. But I mean, that's a piece of evidence that can let other people to replicate the experiment and do stuff like that. I think that's the way experiments should be used and could add to scientific knowledge. So there is definitely this trade-off, but that's at least how I think. What do you think about it?
Yeah. So basically, you said also on these two extremes, right? So. Well, you basically no, it's wrong. You had once the controlled experiment with this narrow, or with this not narrow. The question is very practical, but you need to control for in your labs, right? But so you cannot really say anything about how this works in practice, right? That's right. So the idea there would be, for instance, to have to from this broader research question, which is very practical, to extract the key mechanisms, that the key causal mechanism maybe that would be required in order that you can answer this practical research question positively. So for instance, when you have a research question like, does this code review approach work in practice? When we ask the manager twice about our commits and not once, I don't know. Then you have, it depends on what reviews, what managers you have and whatever. But you can, what's the key ingredient to someone show something 2 times your work, right? And if you find something like showing someone 2 times the same thing, it improves the acceptance rate, because the first time someone just looked over it and did not took it seriously, but the second time it was taken seriously. Then in your lab, you have already found some causal thing, right? Which is not realistic, but you get evidence about that. And then you can come back, and if you now see in a company that also this works, right, it makes the company results stronger, that you have shown it in your controlled experiment, because you have there found a causal relationship, and it makes your controlled lab experiment stronger because you have a different setting, which is also now even a practical setting. So that's what I meant. You need both things, right? And you both should be concerned with a research question. The problem is that currently you can maybe publish the work at the company, but not at your lab, right? But I don't know that you did it in a lab, because it was not published, so I cannot trust the results, right? And that's the issue, right? That we face, yeah, basically.
Yeah, sure. Also, there is another thing, which is, I used to say, maybe run the control experiment to have some evidence to convince the company to let you run a case study, probably not an experiment, because the controlled thing is really what is not that practical, right? So you have, in practice, you don't control stuff, that they just are there. So this is another way of seeing, not like a research life cycle. So you have a lot of cycles that can go on, and then the experiment is just the beginning of it. That's what I used to advocate.
That's right. That's just the beginning. So there are really good talks about research methodologies, and there's also a good book, Empirical Methods, Contemporary Methods, Empirical Software Engineering. So that's I'm not the author of that book, but there are some interesting methodologies in there. So I really urge everyone concerned with that research to read into research methodologies and get familiar, at least at some of them that apply to your own research, right?
Cool. Yeah, great. So I'll ask to invite everyone to open the camera so we can thank Norbert, and Ivan wants to get some screenshots also to register the moment. Cool. Nice people on the cameras. Why you guys don't use open cameras all the time? It will be much better. Yes. So look at this. So Norbert, with this, I thank you very much. It was really a great talk. That will be a must-see talk for my course for sure, and for everybody here. I'm glad this is on YouTube now. So thank you.
Thanks.
Ivan, take the shot, Ivan. Come on.
I'm doing